These factor by grouping questions are a little different because they all involve a difference of squares. So we're going to group this a little bit differently. In this polynomial, we have x squared plus 2x plus 1 minus y squared. So there are two perfect squares here. Here's our different sign, but that's not the difference of squares we want yet. Do you see these first three terms here? We want to actually factor that. So x squared plus 2x plus 1. Let's factor that. So in front of our x squared, we have a 1, and that means we can use sum and product. So we're looking for two numbers that multiply to give us 1, but when we add those two numbers, we get 2. And well, that's just 1. That's our number, 1 and 1. So if we factor out those first three terms using sum and product, we're just going to get x plus 1 times x plus 1. And then we keep that minus y squared. That doesn't go anywhere. But x plus 1 is there twice. That's the same thing. So this could be written differently. This could be written as x plus 1 all squared. And then we have that minus y squared at the end. So now we're left with something very special. We already know that y squared is a perfect square. But x plus 1 squared, is that a perfect square? Well, yes it is. This just means x plus 1 multiplied by x plus 1. X plus 1 multiplied by itself, it is a perfect square. So we need to treat this like a difference of squares, because it is. X plus 1 squared is our first square, y squared is our second square, and they're being subtracted. So what we need to do is we're taking x plus 1, which is the square root of x plus 1 squared, and then y is the square root of y squared. We put a plus sign in between those two things. And then we write almost the same thing in our other bracket. So we have x plus 1, but we're going to have minus y this time. And we can actually get rid of these brackets here, so it's just going to be x plus 1 plus y times x plus 1 minus y. And there you have it. That is the factored form of our original expression. That's it. So let's do another one. We have our four terms, x squared minus 6x plus 9 minus 4y squared. So let's leave that minus 4y squared alone and deal with these first three terms. Let's factor it. So we can use sum and product. We're looking for two numbers that multiply to give us 9, but when we add them, we get negative 6, and that's just negative 3. So when we factor this, it's just x minus 3 times x minus 3. Okay, notice that these two binomials are the same just like we had last time in the last question. So this is a perfect square trinomial, and it can be written as x minus 3 squared, because it's a perfect square. So how do you know when you have a perfect square trinomial? Your first term and your last term must be perfect squares. And if you took the square root of that first term, so square root of x squared is x, the square root of that third term is 3, and x times 3 times 2 will be the middle term. And then these signs would just match. So if it's a negative, these are all negative. If that 6 was a positive 6x, then these would be x plus 3. But you could just use these formulas and follow the pattern. But if it still doesn't make sense, just use sum and product. So going back to the question, we factored the first three terms, and we still have this minus 4y squared at the end. So we've been left with a difference of squares here. X minus 3 squared is a perfect square, 4y squared is a perfect square, and they are being subtracted. So we're looking for the square root of x minus 3 squared, and well, that's just x minus 3. And we're looking for the square root of 4y squared, so that is just 2y. And we need to add those, and we're using those exact same things in the next bracket. So x minus 3, but this time we're going to subtract 2y. And we can get rid of those brackets around the x minus 3. So this would be our final answer. X minus 3 plus 2y times x minus 3 minus 2y. And that is factored. So here's a challenge question for you. We have 4 terms here. There are some perfect squares, a squared, b squared, 25, but it looks a little confusing. So I want you to try to factor this. So pause the video and then come back when you're done or just really stuck. So if you're coming back to the video, hopefully you've noticed that you may need to do some rearranging in this expression here. So there's a minus b squared here. It's the only term that has a b, so I'm going to take that out. I'm going to write it at the end. So really I'm just moving it away. And then we have a squared plus 25 and plus a 10a. Well, I know that a squared and 25 are perfect squares. And well, 10a happens to be a times 5 multiplied by 2. So that would be our middle term if this is a perfect square trinomial. So I'm going to rewrite it like this. A squared plus 10a plus 25, and then keep that minus b at the end. And we can factor the first 3 terms. That's a perfect square trinomial. So I'm just going to go right into it. This would just be a plus 5 squared. So a plus 5 times a plus 5, and we're keeping that minus b squared at the end. And just like the other questions, we have a difference of squares. A plus 5 squared minus b squared. So the square root of a plus 5 squared is just a plus 5. And square root of b squared is just b. And I'm going to put a plus sign there. And we'll write the same thing, a plus 5. But this time we're subtracting b. Let's just rewrite it without the brackets. A plus 5 plus b times a plus 5 minus b. And that's it. So sometimes you may need to rearrange your original polynomial to get what you want, but that is now factored.